So welcome everyone. I'm Dr. Lisa Hicks and welcome to our 2021 Sustainable Product Design and Innovation Senior Portfolio Review. So joining us on the webinar are the rest of our SPDI, we call it SPDI for short, faculty and staff team. Curtis Mead and Warren Hurd, our invaluable lab managers and skills instructors, and also Dr. MD Hassan Habib and Dr. Jared Nelson, who have joined me as faculty members in our SPDI program. We've had a full year of in-person classes and classes attended on Zoom, screen sharing presentations, sharing on OneDrive, sharing Google Sheets and Google Docs, Zoom design reviews and lab instruction. And we've also had a lot of in-person experiences, discussions and presentations in classrooms, hands-on demonstrations in the labs, modeling and making projects in the labs. We also have new equipment that the students have helped us set up and that we've all been using in our courses. We've had quarantines, we've had isolations, and we've been testing twice a week for COVID-19. So we've had a very full year and we're very proud of what the students have accomplished. So welcome again to our 2021 Sustainable Product Design and Innovation Senior Portfolio Review. So for this event, the chat's been disabled. So if you have any questions or comments, please put them in the Q&A anytime during the presentations. The students will present their work, and then we'll have some time at the end for shout outs and your questions and comments. So with that, I'll hand it over to Liam to start us off.
Hello, everyone. My name is Liam, and I'd like to welcome you all to the Sustainable Product Design and Innovation 2021 Senior Portfolio Review at Keene State College. This is our SPDI graduating class in front of the TDS. The TDS over the years has been a place for my classmates and I to explore new ideas and build a strong sense of community. We've all learned to value research and understand the needs of end users. Valuing design thinking allows us to create useful products based on the needs of users, as well as combining classical and digital manufacturing technologies to get us there. We've also explored both positive and detrimental impacts on health, so we're well equipped to be making the right decisions when it comes to promoting a more sustainable future. So before we dive into everybody's portfolios, I'd like to talk about our capstone course. It's called Manufacturing Enterprise. Real quick summary of the course. It's designed to give us a brief taste of what it's like to be in new product development and all the challenges and hurdles that comes with it. The class was divided into half, and each group had to come up with a new product to manufacture a pilot run of 10 units. So that entails designing it, what materials are we going to use, testing it, jigs, fixtures. And you're going to see that within everybody's portfolios, they will have a slide dedicated to what their contribution was. Now I'd like to introduce my group that designed and manufactured 10 units of the pendant light. This light is made of 2 sheets of wooden veneer that are illuminated from an LED inside. Now I'd like to introduce Zach, who worked alongside me.
Yeah, as you can see in these images here, as Liam mentioned, we created a run of 10 pendants for the project. For this one, it was the first of the lights that we completed, and it was installed in one of our team members' homes.
So we've got a couple of jigs that we used. That was built by Zach and Aiden. This is that same jig in action. We're sanding off some excess veneer. And we did some 3D printing. This is printing the canopy that actually mounts to the ceiling. And then here's the final product, hung up.
My name is Mark. I was the manager of the other group, along with Ben, Jack, Chris, other Ben, and David. And we made an electronic headphone stand. So we did a lot of user research to see how many devices people had that they needed to charge at once, and what materials we should use to match the majority of desks and things like that. And this is what we came up with. It's a wireless charging headphone stand. So that black box in the center of the base is a wireless charger for your phone, and there's USBs for 2 more devices, the headset and something else. And it also has customizable LEDs.
Hi, I'm Ben Cranach, and I worked on this project with Mark and the rest of our team. And this is just a short commercial documenting our processes along the way that was used in our final marketing when we had to sell this finished pilot run.
So throughout the process of making this, we went through a lot of different design iterations, and it slowly evolved through the user research that we did. The first thing we got rid of was the wire coil. We scrapped because no one actually takes the time to coil up their wires. And then we replaced that with a clip. And then we found that most people don't even use wired headphones anyway. So we ditched the wire clip altogether and moved to focus more on the electronics and the lights. And our original design, you can see being put together, was made of routed wood, and we moved on to laser cut MDF instead because it was much faster and more replicable. So the finger joints made it super easy to assemble. Everything fit together perfect the first time, and we were able to make our assembly process and our cycle time way shorter with that redesign.
This is a couple images of our final design. There you see the Solidworks drawing all exploded with our parts, and next to that you'll see one of our finished products. As Mark mentioned, we finished using acrylic and MDF as our final materials, and we went with a number of different electronics sourced from a variety of places, primarily Amazon, such as our small RGB lights that show through the acrylic arm, with one wireless charging dock and 2 additional USB charging ports for any other user needs.
Hello again, everyone. I'm Liam Sandin, and I'm a senior product design and innovation student, and this is a summary of my portfolio. I was the manager of the Pendant Light Group, and so it was my job on deciding who's doing what, when are they going to do it, how are they going to do it, what do they need to do it, and who do they potentially need to reach out to. To better communicate that, I'd set targets for everyone using Gantt charts, telling us what needed to get done and when. To make the manufacturing process repeatable, a well-defined process sheet and work instructions were developed. A great part about this project was my team. Zack, Seamus, Hayley, Isaac, and Aiden were all incredibly hard workers, and they gave me the confidence as a manager to take a slightly hands-off approach and allow them to just do their thing, which in turn gave me more time to do my thing. The ergonomic spoon. So this project was obviously focused on ergonomics. I developed a spoon for people with arthritis in the hands who maybe need a larger grip. I started off with numerous drawings of what might be a good grip. I used clay and slowly progressed through soft foam models and ended up with what you see here. This right here is an eco-design analysis project. We deconstructed an incandescent light and restructured it to be made of more sustainable materials and utilize LEDs. So I designed the Helix Lamp. It stands about 2.5 feet tall, made predominantly of wood. And to get the semi-spiral shape, I had cut angled notches into a piece of wood and then coated it in glue and wrapped it around a large trash can and set it overnight. You'll also notice that the LEDs are sunk up into the top of the lamp And when it's turned on, it reflects off of the inside of the entire curve. This product actually came from my personal experiences. I'm sure quite a few of you reuse plastic bags to line the inside of like a small office trash bin or trash can. The research on this particular problem said that users wanted a way to reline their trash bin quickly and not have to store bags in a separate place. After a few design iterations, the Second Life trash bin was born, and the bin has a compartment underneath to house the unused bags and can hold up to 20 new bags in the channels on the sides of the bins. This was designed last year as an interactive children's museum exhibit, teaching them about the additive light spectrum. We conducted a ton of observational research, which in turn gave us insights on what our exhibit needed to do to compete with other exhibits in the museum. We had done a ton of ideation and a ton of testing to figure out what the client liked, and eventually ended up with this enclosure that had 3 light cannons, housing a green, a red, and a blue light in each of the cannons. The cannons are designed with a wheel to be spun, making the light separate and then combine to yield white light. The enclosure hits 3 of our big target points, one being it allows the kids to take control of the exhibit and make decisions for themselves without any adult supervision. 2, it has multiple cannons, so it can be shared with other kids. And 3, it's pretty easy for anybody to walk up to and immediately figure out how it works. This was just a real quick exercise. We only spent maybe 2 days on this. We had to very, very quickly come up with an idea on how to hold a phone in a very specific situation and how the particular product would function. So Bluetooth doesn't work in water. And so I developed a way for you to hold your phone on your thigh to track your times and play songs while swimming laps. Designed for manufacturing and assembly, this was a course where we took an everyday item and took it apart to understand how it was manufactured and why it's designed the way it is. We learned about a bunch of different manufacturing techniques associated with our parts, such as stamping for this particular piece, overmolding. This is the knob used to control water pressure. We also spent a bit of time on understanding why some materials were selected for certain parts over others and the costs associated with those parts. We then developed tooling cost sheets to be referenced as estimates to tell us how much each mold or action needed to create the part would cost. And finally, we combined all of them with the labor rates, which gave us an estimate as to how much the item would cost based on a run of 20,000 units every year for 3 years. Okay, last slide I'm going to talk about is my internship that evolved into a job. I had created about 100 new product drawings for Hyperia lighting, as well as 3D models encompassing most of the company offered products. Within the drawings, a customer could select a decorative shroud, a pole height, pole style, pole finish, color, and any other accessories that they would like to accompany the poles. And then at the bottom of each drawing, I developed a code associated with all the options selected on the drawings. So that customer would have an ultra specific ordering summary of their particular poles. So I'd like to thank everybody there at PLP for giving me an opportunity to work in my field of study. And with that, I'm going to welcome Ben for his portfolio. Thank you.
Hi, I'm Ben Cranach, and I'm a senior here in the SPDI program. This is just a quick little glimpse of me, some of the skills that I've possessed and gained over the last couple years of schooling, some quick look at me with my Bachelor of Science and a management minor. Call myself a self-motivated, hard-working, quick-thinking, creative problem solver. So as mentioned earlier on, this is the wireless charging headphone that me and my friend Mark briefly presented to you. I got the pleasure of being the accountant in this project, and that was something that I had never really done before, was look at the cost of a little pilot run the size that we did of 10. I helped in design, production, a little bit of the marketing and the final assembly. I was also responsible for making the majority of that short commercial you saw that helped us sell our final product, and I was in charge of setting that price point too. You see that we reached a nice $70 price tag in order to recoup some of our production costs and our R&D costs. And you see we're making a little bit of money here on this project. So as the accountant, I would say that that was a really big thing to learn and experience. This I worked on my first year here at Keene State. We worked on a project where there was a hand or just a human body interface with the object. And so I worked on, initially, it was supposed to be a brush that, you would scrub your dishes with. I was going to gift it to mom or something nice. But upon finishing and going through a number of designs, you see starting with soft foam, clay models, and then one final model in hard foam. After I had given it to the end user, it turned out to become more of a tile brush, as it had the same capability I was looking for in providing maximum downward force, but it was kind of elongate enough for the hand that it worked better when it came to scrubbing. This was our design for manufacturing and disassembly and assembly class, where we picked an item and had to take it apart and learn the inside and outs of it, and tracing it all the way back to the labor costs, the tooling costs, and how much of those big costs account for the little cost in making the product. So as you see here, I chose a cheap little $5 air pump from Walmart. Going through the process was very cool, as calculating the labor costs was something you had to go and explore foreign policies for, and foreign wages, looking at how China prices things like that, knowing that this came from overseas. And in the end, it was all for the purpose of calculating based on what I figured and tested each material to be, and I found them to be orderable. It was to see if I could find a price point that potentially this company could be making each individual product for, based on how many they could be selling each year. This was probably one of my favorite projects because I learned an incredible amount from this one. I was interested in finding a way to organize my gaming setup. And I have a PlayStation with around 10 games or so and a couple controllers, but I had to go out there and look at my user market. I had to go and see if other people had the same problem that I was experiencing. So upon doing a bunch of research, you see here on the left, I created a hierarchy of needs, starting with the physiological stuff at the bottom, just having this console and the controllers in hand, versus what people actually look for when they're playing these video games. What does this gaming entertainment center need to have in order to satisfy these people? What does it need to do when it organizes, not just how it organizes? So as you can see, I started with a number of sketches. There's one in the bottom left, and I moved over to CAD. You can see there were a number of prototypes that I made out of cardboard, and I looked for something that worked well and settled on there. On the right side, you see I worked with all wood, which was one of my biggest learning mistakes, I would say, as it was one of the heavier mediums I could have chose. I learned a bunch along the way, as this wasn't the only wooden prototype I made. I had experimented with a couple different types of birch, and a lot of the redesigns and a lot of the original requirements I had didn't necessarily make it into my final product. After making 2 prototypes and calling one the final, I would go much further into this project, as there's still a number of things that I left unsatisfied for myself, which I believe would lead to the same result in my consumers. When I was a junior, I have to say I'm very thankful that I got the opportunity to get hired at Electronic Imaging Materials here in Keene. I didn't really know what I was going to be doing when they first hired me as part of their sales and estimating department, as it was a brand new department there, and I'm not a finance or economics major, so I wasn't really sure what I would be dealing with at first. But learning that whole system for my first semester junior year was a very cool experience. Before my second semester junior year, I was moved into the new product development and research department, where I was given free rein to work with their different materials and certain printers, cutters, barcode printers, and all of that. I've become a bit of a label expert, they would say, and I must thank them for that. And along with that, I would definitely thank all of my professors here at Keene, because in this program, I learned an incredible amount about being a designer, and I can't wait to apply it out there in the real world.
Good afternoon, everybody. My name is Isaac Keene. So I was a 4-year member of the Keene State pitching staff. I enjoy fishing and being out on the water. I'm team-oriented. I'm a hard worker, creative, honest, reliable, and adventurous. Some skills I have obtained while in the SPDI program are becoming proficient in SolidWorks, learning how to sketch and draft my product ideas, creating rapid prototypes of these ideas. Also, my problem-solving skills and time management skills have also improved quite a bit. Here is a baseball display shelf. It was a project in our Product Design 2 class. It was a heavily research-driven project that required research on its end users as well as current products in the market. Prototyping was also a huge part of this project and allowed us to build those skills and learn from our mistakes. This is showing the process I went through in coming up with this product idea and its final form. First, I found a need and found that some users in the niche that I could interview and understand how they interacted with their displays and how I could possibly improve it for them. Understanding what was most and least important from these interviews was then formulated into a hierarchy of needs diagram that allowed me to prioritize some of the different things I was trying to break down. This is showing the process I went through in coming up with this product idea and its final form. First, I found a need and found some users in the niche that I could interview so I could understand how they interacted with their displays and how I could potentially improve it for them. Understanding what was most and least important for them was then formulated into a hierarchy of needs diagram that helped me prioritize some of the different factors I was trying to break down. I then began to research existing products in the market and compared them based on their price and intricacy. And after that initial design research, I began my own ideation with some sketches and possible forms that could solve some of the issues that I found. When I found the final form I wanted to work with, I drew a full-size sketch on graph paper and used this sketch to build my first prototype out of cardboard. After that first prototype, I was able to make some improvements in a hardwood version shown in the bottom left. The dovetail groove that holds the front face onto the sides was the most important detail and was executed during that final prototype. The Solidworks models were another key part to this design, as they let me see the form before I was actually finished with it in wood. And the reason I chose this material in the first place was partly because of its ease of access in our lab, but I also enjoyed the versatility of the material and how I could customize it with different stains and finishes. This was a project in our Design for Manufacturing course. The class consisted of finding a product with multiple materials, disassembling the product, and then weighing and determining the materials of the individual pieces. We then created a SolidWorks assembly of the part as well. Here are some of the slides that I used in my final presentation for the class. The images on the top are the breakdown of the parts and what materials I determined them to be based on some tests. For example, using a magnet to determine that it was made out of stainless steel or polystyrene due to it sinking in water. On the right is the labor and routing sheet. This is breaking down the move and labor time, the cost of producing each part. The bill of material sheet is breaking down each part's material, its weight, its cost per kilogram, existing cost, and overhead costs. The ones highlighted in yellow are indicating which parts were purchased and not necessarily made in the production line. The materials and process sheet then indicate the part, the material it was made out of, why this material was chosen for the specific part, and the process that is used to make it. The tooling cost sheet simply states how many cavities each injection mold has and how much each costs to determine the overall cost of one singular pencil. This was a very detail-oriented project that required me to know and understand the different manufacturing processes of making a pencil like this. It also challenged my measuring skills as well as creating my SolidWorks models, which was quite a challenge. So this was one of our projects for our Product Design 1 course. The goal was to build a chair strictly out of cardboard with no adhesives. It also needed to hold the weight of our bodies for the duration of an hour and 30-minute class. So to begin the course, we did some research on structure and how different forces acted on different structures. We then made a 1/4 size version of the chair that we wanted to build to prove its form and function, and that's pictured in the middle left there. We then took our anthropometric data, which is different measurements of our body and how they correspond to sitting and standing. And we then applied that to our full-size models. So I chose to do a triangle structure on my interior of my chair, as well as using structural support and tabs to hold it all in place. This was my project for our manufacturing enterprise class. It was a group project where we researched and developed a hanging pendant light. The electrical portion was the portion that I focused on along with another one of my classmates. It needed to be compact and have the ability to hold the weight of an entire piece. We decided to use LED light strips for their powerful light output, low heat emission, and easy application. A wire strain relief was then used to hold the pendant light as it was being hung from the ceiling. And LED light strips were applied to the inside edge of the MDF frame and provided pretty good ambient light to the surface below. The wiring was then fed through a hole in the MDF frame to attach to the canopy electrical, which consisted of a 3D printed mount that some of our group members worked on, as well as a power supply unit and other wire connections. This slide is showing some of the parts that I built in our advanced 3D CAD course. It was one of the several SolidWorks classes that we took. We worked through a textbook learning the different techniques such as lofts, sweeps, extrusions, and more to create different complex 3D models. The part pictured in the middle was once a part of a lawnmower that was taken apart, and each piece of the motor was handed out to different classmates, and we were told to take different measurements of it so we could then build it on SolidWorks on our own. I would then like to finally thank Mark and Mamaj for welcoming me in as an intern in the end of 2019. I was a production cell assembler where they taught me how to assemble some of their printer heads, as well as put together some of their kits that they sent out to their customers. It was a great experience learning how to work, what it's like to work in the field of manufacturing, and I met some very great people there. So thank you very much, Mark and Mamaj. And now I'd like to pass it off to my classmate, Ben Musese.
My name is Benjamin Musese, and I'm a SPDI major at Keene. Little about me, I played 2 sports. Since freshman year, I'm playing all season for soccer and all season for track. I know myself as a creative, and I love creating stuff on my free time. Here's a cool project that I thought about it. LED lights. Most people scared of the dark. I'm one of them. So I wanted to create a little picture of a lion, because most lions are scary but a little protective. So I thought about being more creative. I went and I sketched it out first, and then I went to SolidWorks. Sketching in SolidWorks, it kind of took me a while because I was trying to get the edges. But at the end, I still got it, and then I went to laser cut and then cut it out. But I still have until now. It's very helpful. I put a lot because I'm in a dark room right now. I usually just put it on and it switches color, which is cool. It shows the whole picture of the line. This is my pillar handle design. I want it to be like a knife handle, but it turned out to be a keychain, which came out cool because I had to design my name on it too, and my brand. So I use this for my keychain. I still have it right now with me. Oh, so this is the cool lab, which I find it very interesting. When we did this in a material class, we had to use the machine pressuring. I was surprised. I never knew how the wood could bend one of those pictures over there, which I find it pretty interesting and amazed about it. I just thought when you press wood down, it would just snap, but turned out to be bendable. And quick cool. The poly assembly. we did this in CAD class. This picture right here is we did we sketched it out first, and then went in the SolidWorks. This took a long time to make it because you had to get every part of it. After that, we had to go on do the engineering part, which took so long to get every part of the whole poly. This is mostly used for boating or fishing. Most people, I've seen it multiple times. I just never used it before. I never. One day maybe I will. Ooh, my favorite of all time. So you know how people struggle watching, like say you want to watch a movie or watch a video on your phone. Some people get tired of holding on their hands. So I created this karate phone stand, which it looks cool in every angle. You could be like bored and watch a movie or a video. You just put your phone right there on the side or next to your bed. You could just watch a movie on it, and it won't fall off. So I thought it was cool. Great. Cooking. I myself is a chef. I love cooking so much. So I've had struggle using a cooking spoon over the years, and I know most people have struggled too. So I did a little research and went to ask people around like what type of spoon they use mostly. So if you look on the left, there's a picture of people like showing me how they use the spoon and how they're struggling with. So I came up with the idea of like a spoon that will protect your hands from burning, flashing oil, which is on the right. If you can see the every angle of it. I still have this spoon right now, and it protects me from whenever I'm cooking. My hands doesn't burn anymore, and I thought about. I just think it's a cool best thing I've ever done.
All right, hi. My name is Mark Torselli. I'm a sustainable product design major here at Keene State with minors in business management and environmental studies. I work extensively in 3D CAD. I'm very proficient with SolidWorks and also familiar with Rhino and AutoCAD. I have a lot of experience with additive manufacturing, particularly 3D printing, but also subtractive methods of manufacturing like CNC. I love working with my hands. I love solving problems, and most of my passion lies in the prototyping stages of design. All right, so first off, because it was my original design that was chosen, I was made the production manager of the group for the electronic headphone stand we talked about before. I was a very hands-on manager. I worked extensively in every aspect of the project through the full design process to the electronics, the prototyping, the laser cutting, the manufacturing, the assembly, the sale, all of it, making sure to use all our managerial tools to keep my group organized along the way. We built and sold all 10 units for a small profit, and it was a really rewarding experience, very educational to successfully bring a product all the way from concept to manufacture and sale. Next is the hand object interface project from Product Design 1. The interface I chose was with a utility blade handle. The utility blade I had at the time was basically just a straight rectangle, and it was hard to keep a good grip and it would fatigue your hands. So the redesign focused on improving control and reducing fatigue to minimize the risk of injury. So it has a little hook for your index finger to give you more dexterity. It has an indent for your thumb to give you greater downward pressure when cutting. And a round, more comfortable ergonomic grip to reduce hand fatigue and discomfort. Next is this home palette garden from our healthy lifestyle project, where we were all given an aspect of a healthy lifestyle to make a product for, and mine was mental health. So I designed an indoor garden made entirely from recycled and reclaimed materials. I did a lot of research on studies that show that people who spend more time in and around nature are more mentally healthy. So the idea of this is to make a design that anybody can make at home to bring some of nature into their house. This design was from Product Design 2. It's a modular desk organizer made to be a customizable way to organize the clutter on your desk. So I researched a lot of the competing products because there's a lot already out there. And the hole in the market I found was in customization. There wasn't really much available that was flexible, so I made something that is. It has this grid of magnets, so the different customizable cups can be moved around into whatever orientation suits you best. And everything will always snap into place real nice with those magnets. So depending on the kind of things that you have on your desk, you'd always make it work just for you. You can change it with things changing over time. If you have unique needs, just want to change the scenery, it'll work for just about anyone. And here it is, redesigned for manufacture in our DFMA class. The redesigns include remodels, drafts, fillets, tolerances, all to make it able to be injection molded for mass manufacture. I considered a bunch of different plastics to find the ones that would fit best. Everything was priced out, from the materials to the labor, the tooling, factory overhead, all that kind of stuff. It was I compared the prices for China and recosted everything in the United States as well to see how big the cost difference would be. I made all fully detailed dimension drawings for every single piece. So this design could feasibly be sent to a tool maker today to have the tool made or the mold made and start manufacturing. This here is my little piece of the new mechatronics and automation class. I worked on one part of a larger automated candy dispenser. So I laser cut and 3D printed the parts, then did the assembly, wiring, pneumatics, programming for the cup dispenser that dispenses the cups the candy go into. And then after that, the cup would go down a conveyor belt, be scanned by an optical scanner to see how big it is and determine how much candy should go in. And then the candy was dispensed into the cup and delivered to the person. This here is the first Product Design 3 project that I worked on. The Monochrome Room was an exhibit developed for the McAuliffe Shepard Discovery Center in Concord. The exhibit was made to teach kids about the interactions between light and color. So the way it works, as you can see in the little video there, is the lights change. Well, there's little colorful pictures that one of my group mates, Aiden, made, and they're up on the walls in this enclosed room, and the lights change colors. And as the colors change, the pictures appear to change with it, even though the picture stays the same. So it kind of looks like they're almost moving. The colors are changing, appearing, disappearing under the different wavelengths of light. And there's little educational blurbs around explaining how all of that is happening, so it can teach the kids the science of it. This slide here is just a quick showcase of some of the flashier things I've done in CAD, most of it in SolidWorks. Actually, all of this in SolidWorks. There's no Rhino models here. But as you can see, there's dimension drawings, stress simulations. I've made molds for injection molding. I've worked a lot with the sheet metal tool, all that good stuff. Wouldn't say I'm an expert, but haven't found anything I couldn't model in SolidWorks, at least not yet. This here is an ongoing project, so since it's still in progress, all I have are pictures of the cardboard mock-ups. But the project is making an adapted croquet mallet for a friend who got into an accident and is now paralyzed from the chest down, but he still likes to enjoy a lot of the activities he did before, like croquet. Problem with croquet is it's really difficult to swing that mallet, the standard mallet, from a wheelchair. So for class, my partner Jack and I are making a adapted one for his wheelchair. So the way it works is there's two parts to it. There's the lap bar, like you can see in the top right, top left, sorry. So he can swing it from a straight upright position without having to lean over because he doesn't have that abdominal control. It's difficult for him to lean. And he can get that control and strength in the swing comfortably upright. But then the side piece, the mallet, detaches from that with an adapted handle for swinging, so he can swing from his shoulder instead of his wrist. So for more dexterous shots, he can lean over and use just that piece instead of the lap bar. And finally here we have the research I started last summer. I've been working on over the semester with Dr. Habib and New Hampshire Biomaid. So this has been my job for the past year about. The research is in 3D bioprinting, where I'm designing a new kind of nozzle for the 3D bioprinters. And the nozzles are to print hollow tubes to aid in vascularization of printed cell masses. So with these hollow tubes integrated into prints, the nutrient fluid can flow into the inside of the print to reach the cells in there and keep them from starving. So the idea of this is to make a nozzle that can be replicated by other labs to aid in their research and take the whole field that one tiny little extra step forward.
How's it going? My name's Aiden Bowen. So I'm also a senior here in the SPDI program. I like to spend a lot of time outdoors. Like to think of myself as a team-oriented person. Couple of my skills here, rapid prototyping, creative problem solving, ideation and product development. And then there's some classes there at the top that I really enjoyed and spent a lot of time working on projects in. So these were some early projects from my first semesters here at Keene. And I came in as a SPDI major, really wanting to do the program, and fell in love with it pretty quickly with some of these models that we did. The first was a cardboard chair. The first and second were a chair and a table, and they were the same project that was brought into the Product Design 2 class. So I was able to do a chair and a table, myself and several other students. These were kept together completely out of just single ply corrugated cardboard. And I actually lasted quite a long time. Both of them held several of my friends that were on the heavier side too. So, and they lasted multiple months. Got a lot of use out of them. There's a cardboard sink model here that was kind of a modernized observational research project that we did. So those were really fun. So for Product Design 2, we had to do a project from the start to the finish, the full product development. And this was a slide for more of the research and development of it. And my project that I chose to pursue was a step seat. And this was used originally. I wanted it to be an organizational tool as well as aid for home access, both in high to reach places and etc. But I realized quickly that it took a lot of space up as it was sitting stationary, not in use. So I wanted to have a multi-purpose. And because of this, I realized that I wasn't able to store cleaning supplies for the household use on the product itself. So I ended up switching the design. I used this entire product. I made it with dovetail joints and Russian birch. I try to take a sustainable approach without using fasteners. Helps with both economics and sustainability. So I did it with just the wood. This is my final slide here of the product. Special thanks to Zack for modeling it for me here. This, like I said, was made entirely of Russian birch. So the multi-purpose aspect of it was that while sitting idle, not in use, I could also flip it and it would be a seat. So put it in the corner and somebody could easily just hop right in the living room, extra seat, flip it over, access anywhere you need up high. So this was some wood and metal fabrication that I'm just showcasing here. And this was also very early on in the first couple semesters in the SPDI program. I really enjoyed these as well. This was a bottle opener key fob. I also wanted a multi-use and have it not just be a key fob for show, but actually have a purpose. So that was fun. I did a little bass. I have some woodwork here, some lathe turning, some chiseling work on some bowls, and a multi-axis, multi-drill countersink piece here that we have all done. And this was our product design 3 project. It was a museum exhibit for the McAuliffe Shepherd Discovery Center in Concord, New Hampshire. This one was a lot of fun, especially in the research and development. We were able to go to the museum, talk to the kids, interact with them, figure out what exactly would be a desirable exhibit based on these Omega optic filters that we were donated to implement for a light-based exhibit. So our group composed over 40 exhibit concept sketches. We met with the museum staff multiple times, and we came to the conclusion that this would be a great exhibit, a monochrome room. Now this was handicap accessible, and we drafted it up on Solidworks, made some interior imagery that the children could both view and color to bring in and see the phenomenon of the light changing. And Mark had a nice slide of this that showed the phenomenon of the color. Actually, as the light changes, you're able to see different colors, and some disappear as the color of the light changes. So this was really cool. So for advanced CAD, we did a small engine parts disassembly and assembly. Each student was assigned a part or two from a lawnmower that we disassembled. And we then sketched and 3D modeled these parts toward the end of the semester, showcasing our skills without any instructions. So this was a lot of fun. I had a steel exhaust shroud and a plastic carburetor connector. Nobody had pieces. Nobody had the carburetor just because of its complexity, so I wasn't able to make an assembly with that. And I believe the same with the exhaust. So either way, these parts were really fun to make and complex. So for the manufacturing enterprise project, I was in the wood pendant light group. I did a lot of research and ideation based on Liam's original design. Did some veneer treatment, and I primarily worked on jig construction. This was because I was in the quality control sector. So that really helped get our product looking as good as possible and get the assembly line process most efficient. So the jigs that we had that myself and Zach made were a squaring jig, a sanding jig, a press jig, and we made prototypes for all of these as well to make sure that these were correct and fitting the product perfectly here. And these are a couple of final slides. The one on the right there, Seamus showed, that's in his house. There's the veneer treatment after outside drying, and this is our press jig on the left. It secures the veneer to the frame. So the last slide I have here is a new class offered in the SPDI program. I was really lucky to be able to take it. There were only 6 students in this first run of the course. And it was an ultra precision manufacturing course. We had the Nanoform X by Amatec Prestatec. This machine, very expensive, ultra precision diamond turning machine. And we're able to make different types of lenses with this diamond tool and lathe turner. In these pictures, I'm actually video tool setting the diamond tool, so that it is set at 0, so it's properly programmed. And we used DiffSys, which is a software to write programs to make both Fresnel lenses, aspheric lenses, and spheric lenses. And then we had this little project to make eye loops, little mini microscope deals that you can see things up closely with. So these are really cool. We 3D printed the housing. So Jim Wing was the instructor for this class, and he's going to do a lot for the optics program here. It's growing a lot in Keene, and yeah, I'm going to hand it off to David now.
Hello, my name is David Arduino. I am a 22-year-old senior at Keene State College. I enjoy skateboarding, traveling, and expressing myself through design. I did a semester abroad in Japan at Kengsai Gadai University. During my time in the major, I have become certified in Solidworks, learned how to operate the laser cutter and the 3D printer, as well as learned Adobe Photoshop, Illustrator, and Premiere. For design for manufacturing class, I chose to take apart a ratchet style skateboard tool. After taking it apart piece by piece, I measured and drew each part in SolidWorks as a 3D model, as seen in the middle photo. Then I figured out the material and processes that were used to make each part. To complete my bill of materials, I figured out the price of each material from its price per ton into price per gram, then multiplied that by the amount of material used to make the part times the amount of scrap material and overhead. To find the cost of labor, I multiplied the move time, labor time, and hourly rates of workers for each process used to create each part. Next is a personal project I worked on with Zack Stevenson. Over the recent winter break, Zack and I built a skateboard press. We created a wooden mold to pour the concrete slabs that the veneers would be pressed in between. To make the actual boards, we started with 7 plies of Canadian maple veneer. We coated each side of the veneer in wood glue and then taped the sides to reduce the slide from the glue. Within 10 minutes of applying the glue, we needed to add the pressure from the bottle jack. So basically, we would just put the veneers in between the 2 concrete molds and then crank down on that bottle jack, and that would give us around 8 tons of pressure. After a 24-hour drying time, I drew the shape on the board and then I would cut it out. And then finally, the boards were stained and polyurethaned, and you can see a finished board on the bottom right-hand picture. For the last 2 years, I have been doing an internship at Rathbone Precision Metals. It is a custom manufacturer of precision cold drawn and cold rolled metal profiles. Some of these profiles include orthopedic rods, gears, and turbine seals. While there, I worked with the engineers, drew a floor layout of the factory on AutoCAD, and worked with quality control to find cracks in our materials. I was also able to take the ergonomic assessments I learned from my safety class and apply them directly to workstation processes. Finally, I was a design engineer for the headphone stand project. I designed the acrylic arm and the mold used to give it its curvature shape. I was also involved in the final assembly of each model, as well as in charge of finishing them all. These were my favorite project I've done. The most important thing I learned in my time in the SPDI program is to apply what we've learned in class into my own life and my own projects. Now, thank you for all listening and looking at my portfolio. Here's Seamus.
Hello, my name is Seamus Wibben. I'm 25. I live in Newport, New Hampshire currently, and I absolutely love getting out and riding motorcycles and just generally enjoying an active lifestyle. This is the screwdriver redesign that I did for my hand form project. It was made to be able to provide more torque and more stability when using screw fasteners. The part that I really enjoy about this is the first project that I did in the SPDI program. And I really enjoyed the process that it took, and it actually inspired me to pick it up as a major. This is my CAD model project. We, as a class, disassembled an entire pressure washer and divvied up the parts across the entire class. And I sketched out and 3D modeled the piston, the connecting rod, and the crankshaft. Here we can see the piston. On the left is the original piston. The center is my CAD model, and then I took the liberty of 3D printing it, as you can see on the right. This is a manual milling project that I did for my CNC class. I spent over 30 hours on the Bridgeport mill, milling out these pieces of hard foam, and it gave me an interesting perspective as to what it actually means to make a run of 20 parts. It's easy to say, oh, we're going to produce how many, but to actually get the physical actions of making these parts again and again and again, the repetition, the quality control, and there's a lot of good lessons that were made from this. It also allowed me the first opportunity to kind of acted like a business, where we sourced material, priced it out per square inch, and then actually placed a bid for a contract to make 20 of these puzzles. And my whole team kind of came together, and we were able to complete the entire project, which was a apparent shock to the professor, because it hadn't been completed before at least this format of puzzle. So it was a very proud moment for me. And this is the Veneer Pendant. For this project, I worked as an accountant and as a manufacturing engineer. I leaned more towards the accounting side simply because I hadn't really experienced much of that. I got a little bit of a taste of it with the manual machining project, but I wanted to kind of explore that because it's something that I honestly felt as though I was a little weak in, and I felt as though I could have improved, and I like to believe that I did indeed improve. We were able to source all the parts. We assigned them our own personal proprietary serial numbers to them, and we're able to calculate the cost of a run of 10 units. And it gave me a chance to work with a larger group than I imagined that I would be working with in a learning institution, and got to do a lot of troubleshooting on the production floor, so to speak. And next up is Hayley.
Hello, my name is Hayley Louberty. I like to go fishing, travel, and spend time with my family. My skills are 3D modeling, rapid prototyping, machine operating, 3D printing, laser cutting, engineer drawings. I also have my CSWA certification, and I'm working towards my CSWP. For this project, we had to design an organizational tool to help make people's everyday lives easier. I chose to do a desk shelf since I found the ones we had in the college dorms didn't work very well the way they were designed. After interviewing students, I found that it would be most useful to make the desk shelf adjustable since not all desks are the same size. I also found that it would be useful to add a pegboard, so it made it easy for the user to hang up anything that they didn't want on their desk. My initial drawings and prototypes didn't come out as I had planned since gravity does take effect. So I redesigned it where I implanted drawer slides and mounts for support, as you can see in my functionality test. As you can see in the CAD model, the back wall slides make it easy for any user to select what size they want to make the shelf on their desk. My initial prototype had slides that I made from a block of wood and an aluminum bar. In my final prototype, I used just regular drawer slides and changed the mounts so it didn't take up too much space on the pegboard. For this project, I had to choose a product to disassemble and figure out what materials, manufacturing processes, price of tooling, labor, and routing costs for 1 unit was. I chose to do my computer mouse. As you can see in the picture to the right, this was my mouse disassembled. The bottom spreadsheet shows each part and what material the mouse was made from, as well as the processes that were used to make the part. Most of my parts were made from ABS, with the frame being made from 5051 aluminum. For the parts made of ABS, I was able to determine that they were injection molded just by the markings on the B side of the part. For the aluminum frame, I determined that it was a die cast part just from the features and bends in the part. On this page, I have a CAD model of my mouse. I used the CAD model to determine the mass properties for some of the parts in the mouse. The spreadsheet on the left has the bill of materials as well as the cost for 1 unit. And the spreadsheet on the right has the labor and routing costs for 1 unit. Once this was all put together, the total cost of the mouse for 1 unit to be manufactured was $16.86. I purchased this mouse from Best Buy for $60. This determined that Corsair, who manufactures the mouse, makes $25.70 off each mouse by selling it to retailers for $42.13. These are just some CAD models I've done for past classes. The picture on top was a part of a weed whacker engine that we disassembled and then drew the parts up in Solidworks. Once all the parts were made, we made an assembly of the weed whacker engine. The bottom left is a product I designed for my paired parts project. We had to come up with a design that involved 2 objects that work separately and they also work together. I came up with a ruler that had a pencil inside. This is because when you're using a ruler, the majority of the time you need a pencil. So with this design, you always have both. The picture on the right are just some models I did for my advanced CAD class. These models helped me learn different features and the ways of building parts in SolidWorks. For my manufacturing enterprise class, I was a part of the Pendant Light group. My job title was manufacturing engineer. I worked mostly with the laser cutter to cut the MDF frame and veneer. I also helped make the squaring jig you see in the top right picture and assisted with assembly of the final product. I also tested out materials we could potentially use for our lamp. Our initial material was going to be 1/4-inch birch plywood, as you can see in the bottom left picture. I tested out speeds on the plywood to see what would leave the least amount of charring on the sides, as well as what would cut all the way through. We ended up changing our material to MDF due to our second sheet of plywood not cutting all the way through, as you can see in the middle picture. We discovered that this was because of the glue used in the plywood. Also tested out laser engraving the veneer to see if we could have more light shine through, but this made the veneer way too fragile and took way too long. This was an instruction sheet I made for the laser cutter. It also shows how to take a 1-to-1 drawing from SolidWorks and send it to Adobe Illustrator to get it ready to be cut on the laser cutter. This instruction sheet allowed for any person in our group to make the parts for the frame and to cut the veneer out without confusion, and just made it really easy. For this project, another student and I were assigned to Smiths Medical to assist in improving the performance of their machine Abacus 2. Smiths Medical is seeing a 600% increase in demand for syringes due to COVID. Since a new machine to handle the demand would take 12 to 18 months to create, they were looking to increase their current machines to bridge the gap. The product goals were to analyze current operating states of Abacus 2 and attempt to increase output within 10 weeks. The benefits to this is that all syringes that are made are immediately able to be sold due to the high demand for the product. Abacus 2 currently makes 2 types of syringes, the 3 ml and 1 ml. They also have 3 different tops, as you can see in the top right-hand picture. Currently, Abacus 2 is running at about 60% overall equipment effectiveness. The world standard for OEE would be 85%. In our measurement phase, we looked at the OEE data for the past year and determined that the performance was constantly dragging on overall yield. We met with SMEs to determine what areas of Abacus 2 were problematic. We categorized the issues by locations on the machines and then determined the types of opportunities associated with the issues. The top issues were prioritized and tick sheets were made to keep track of the problems. After reviewing the data from the tick sheets we had deployed, it was determined that the plunger jams were having a large impact on the machine's runtime due to frequent stops. The plunger tips were getting stuck in the cingulate wheel due to the plus-shaped design and the sharp teeth on the wheel. These stops occurred an average of 7 times a day and took about 7 minutes to fix each time. This resulted in a loss of 4,200 syringes a day and 1,533,000 syringes a year. To solve this issue, we evaluated the Cad model of Abacus 2 to see if there was any changes we could make to improve the uptime of the machine. After viewing the Cad model, we redesigned the teeth on the cingulate wheel to prevent the plus-shaped part of the plungers from being stuck. The teeth were previously sharp on the tips, and on our improved version, they are rounded off. To see if our solution would work, a new cingulate wheel was made and installed halfway through the day on May 6. As you can see in the bottom chart here, since the new wheel was installed, there have been no issues with the plungers getting stuck.
Hello, my name is Jack Hurley. I majored in sustainable product design and innovation to prepare and learn how to navigate our rapidly changing environment. Throughout my time here at Keene State College, I've been given many opportunities to explore technical and abstract solutions to consumer products with a heavy focus on sustainability and preserving a healthy global ecosystem. Exploring the research and design process has presented me with many unique challenges and has truly taught me the value of change in a world that often resists it. So for my hand-object interface project, I wanted to improve the traditional handsaw grip to offer an easier time sawing. At the bottom, you can see my progression from a soft clay model to the 2 hard foam versions, and finally to the finished grip with the finger grooves and the handguard. This was a lean woodshop organization with the idea to reduce waste and boost productivity in the woodshop. I identified a problem in the shop with the storage in the back, and the clutter and scrap that tended to pile up left the area disorganized, and getting access to the materials and the tools in that area was often challenging. The goal was to create a series of shelves with the workbenches underneath and tools integrated into the shelving as the foundation. This is a collapsible bike helmet. I identified a challenge with the lack of helmets being used by commuters and students using bicycle sharing programs. I found that though they are not the most fashionable accessory, people often don't have the space to store them when they aren't in use. My solution was to eliminate the rigid structure, allowing it to quickly collapse and return to a normal helmet shape when needed, in the event that if it's small enough and convenient to carry with them, they might be more likely to pull it out and wear it. I was also part of the headphone stand group, and in addition to working on the final assemblies, I did some related product research and looked at the requirements for UL standards and National Electric Code requirements. The fishbone diagram, as pictured on the right, was used to identify some challenges with the acrylic, such as inconsistent molding temperatures and scratches or visual defects. This is an electronics storage case. I was finding that many students, and including myself, have the tendency to throw their devices into bags, and taking the time to rummage through them and all its contents when needing a charger or your headphones was just wildly inconvenient. So I wanted to address this problem by creating a case for the sole purpose of housing your devices. The idea was to have it customizable to fit specific needs of, say, someone who's a photographer or a digital nomad, by shaping the foam insets to your personal device lineup. You can see the design progression on the bottom. I went from very low fidelity prototypes with small storage space to the finished case with handles and latches and extra storage underneath what's in that main image with the laptop and the tablets to fit your wires and any extra small things that you would need to carry with you. This is an acoustic guitar model I worked on in Solidworks. It is an exact replica and a copy of a Dreadnought acoustic guitar, the one that's pictured on the right. The assembly is composed of the 4 main parts: the body, the neck, the head, and the bridge. If I were to continue working on this and do some further iterations, the strings and the tuning pegs and hardware would definitely be added to give it a complete look and assembly. This semester, me and my colleague Mark are working on an adaptive croquet mallet, and the idea is to make the game of croquet more inclusive for people in wheelchairs and paraplegics, and we were able to identify some of the challenges that paraplegics face with the help of our client Daniel Henderson. The new mallet will have an integrated lap bar bridging across the player's legs and allowing them to use both hands to twist the bar to swing the mallet. Thank you, and now passing it on to Zack Stevenson.
My name is Zack Stevenson, and I will be presenting my portfolio next. So as well as a sustainable product design major, I'll also be earning a minor in sustainability. As far as skills are concerned, I'm proficient in the CAD software Solidworks, which I passed the CSWA for. I'm also proficient in PCDMIS, which is a software used in precision measurement machines such as CMMs. Other skills include prototyping, design for manufacturability, jig and fixture making and design, machine operating and drafting. All of this requires knowledge of machine operations and a degree of hand drafting, which I also possess the skills for. As far as interests go, I'm interested in anything adventurous. As you can see, the background picture was actually taken in the Andes Mountains in Peru on a trek that I went on a few years ago. And I also like to work hard in the shops here at Keene as well. So my role for the manufacturing enterprise pendant light team was to design and build the jigs and fixtures necessary to create the sub-assemblies and fully assembled pieces. I also did R&D for most of the materials and processes that would be used. You can see in the top left picture, the press jig that was used to glue the veneers onto the MDF frames. Under that's the sanding jig, which was used to sand away the sharp edges that were created in the press jig. And in the bottom corner is a bit of research that I did as to what kind of backing we would put on the veneers in order to prevent cracks and splitting. In my design for manufacturing class, I decided to reverse engineer a Shimano Shadow Z series derailleur in order to figure out how these products are made and how much they cost to make. Figuring this out included identifying materials and processes used to create the parts, the labor costs for the company, including the time spent moving parts from one machine to the next, tooling costs, and shipping from overseas. I also accounted for a 33% gross product that came out to a cost within $5 of what I purchased the derailleur for. And you can see in the top there a few SolidWorks images of some of the parts from the derailleur that I used to figure out how much of what material was being used. For my product design 2 course, the assignment was to create a storage device. So what I came up with was a drop leaf table, which would store users' plates and utensils while it's in use. The table also folds itself up when not in use and can be stored between the sections of a sectional couch. The pictures on this slide depict some of the research I conducted with a sketch underneath, as well as some prototypes, including early cardboard models all the way up through wooden working prototypes. This is the final piece. You can see some of the processes I used to create the table. First, the wooden pieces were cut, shaped, and assembled into a frame, and then the moving parts were added to the frame. I then put an engine turn finish on 2 sheets of 1066 T6 aluminum and bent and rolled them into shape. Lastly, capping the ends with copper sheeting, which finally created the finished product that you see there on the right side. Over this winter break, I was hired to do some work in the wood shop, creating 10 camera dollies for the innovation grant. These dollies were designed by an architecture student with help from the wood lab supervisor, and that was before I was brought to build them. So in the process of building these dollies, I was able to get more practice creating jigs to make the pieces for 10 identical dollies. I was also able to practice a higher level of craftsmanship than I had time for on projects that I would be working on in school. So the last project that I did was totally outside of school and work, but it came out well, so I figured I'd put it on here. The final products here are frame bags for my bike and my riding partner's bike. I made these bags since my frame is a 51.5-inch frame, which is a really weird size to get frame bags in. There aren't any on the market that will optimize the space, and custom bags cost a fortune. I started out with some cardboard stencils to get an idea of the size and shape that the frame bags would be, and then moved on to create a prototype bag that I fitted to my mountain bike, which is the green one in the top left there. After that, I created the second two bags using number 69 polyester thread and Cordura in order to make them rugged enough to withstand our cross-country trip this summer. This concludes the Speedy Portfolio webinar for this year. We'd like to thank you for coming, and we'll be taking questions at this time, as well as giving out a few live thank yous.
We just wanted to give one last thank you to Dr. Lisa Hicks. Thank you for all of your hard work and time you put into this program. Without you, none of this would be possible.
Thank you, Lisa.
Wow. Well, thank you all. Thank you all. So we can all turn on our cameras now. And I just want to do as we're going to be doing some thank yous here, but I just wanted to do a thank you to Professor Rosa Weinberg for stepping in this semester to teach our Product Design 3 class. She's helped the students research and create some adaptive devices for people with physical challenges. So I know the students are enjoying those projects. And I also just wanted, for all of the students that are graduating this year, we have a parting gift for each one of you that you'll be getting at our senior luncheon on Friday. And these are the 77 heuristics cards that you all have used and for creative problem solving and ideation, and you'll be able to take them with you. So Hayley, take it away.
Yeah, so I just wanted to say, I just want to give a huge thank you to John Tomachik at Smith's Medical. Getting to work with you and your team was an awesome experience, and I couldn't be more grateful for the opportunity.
I'll give a shout out to Dr. Nelson for giving me an opportunity to work with fibers and extract them, put them in measurement, and I enjoy doing that. I hope to do more in the future.
I'm giving my shout out to Dr. Habib. He did an awesome job setting up our entire bioprinting facility, and he helps us a whole lot with all our classes, and he's a great professor and a great guy.
I wanted to shout out Brandon Robb at Rathbone for giving me a chance to do my internship. And I wanted to shout out the Dean of Students, Dr. Carrie Kallick, for giving me an opportunity to teach her son how to skateboard.
I'd like to thank Warren in the machine shop. He's a lot of help. And I'd also like to thank Jim Wing, new instructor for the Ultra Precision class. He has a lot to offer for the program.
I would like to reach out and thank Tim Ruland for his instruction in our metrology and CMM course. It was a really intricate course and program that we worked on, but he was very good at teaching us how to use the program, and it was a great experience learning that instruction.
I would like to thank Patrick Joyce for his time teaching in a unique electronics course and helping us apply that to our work going forward. Thank you.
I'd like to give a big thank you to my family here in Keene at EIM, Electronic Imaging Materials, my friend Juan, and all of my Jasons in the estimating department. Couldn't thank you guys enough for the experience, and I wish it just lasted longer is the only thing.
I'd like to give a thank you to Curtis Mead in the wood shop. I just want you to know that all the extra work, staying late and coming in on weekends doesn't go unnoticed by us. So thank you very much for all of your help.
I'd also like to thank Curtis. He's been tremendously helpful for me from start to finish, as well as Jim Kyle. You're the reason why my roommates and I argue about how things are made. So thank you for that. It's quite a bit of fun.
And I would like to give a shout out to Jim Pelto, who was an instructor who, at least for me personally, definitely inspired me to take this on as a major. And I know that there are several other students here that feel the same way. He was always very dedicated to what he did, and he made it very fun. And Jim Pelto no longer works at Keene State with the Speedy Club, but the students have decided that we would like to give him a gift. And if Hayley can get it up now, it might be a little hard to see.
Yeah.
But essentially
so,
what we've done.
Hold on. Yeah.
Essentially what we've done is we took one of his projects that he did for the machining course, and I made it out of bronze, and we put it on a pedestal and a nice little glass dome for it. And it's all machine to spec, Jim. So you could take your calipers out and check it yourself if you'd like. And then we put a nice little laser engraving in there for you. From the students here and from Keene State and all, we really appreciate everything that you've done for this program. And I would like to do an unscripted thank you to Misty for putting all this together and splicing all these things into the background, both for this and for our manufacturing enterprise project. It literally could not have happened without you, and we
Definitely.
really appreciate it.
Yes, thank you so much, Misty. And so this is, we have gone long, but we'd love to answer any questions. So please feel free to put them in the Q&A. We've got a couple of comments here, which I'll read. So here's from Dr. Habib, says, great job. It was great to see all those accomplishments. I saw all the efforts you all put together and your enthusiasm to achieve them. I know you will be a great asset to whoever you will work for in the future, and wish you all the best. That's great. And then from Phyllis, who actually works with me on the Go STEM initiative for the middle school girls to get them interested in engineering and science. And she says, great presentations all. I have the pleasure to work with several of you during the Go STEM Krista McAuliffe Museum projects and also in the CAD class. Best of luck to all. And so thanks, Phyllis. Yes, that's right. Phyllis was part of being our client for the Krista McAuliffe Shepherd Museum projects. Here we have another comment from Jim Crayley. Let's see, fantastic presentation to all. Very impressed by the many examples and range of skills the students displayed. You clearly have learned a great deal through your experiences, and you've demonstrated that today. So excellent work for all of you. Great, thank you. And then, oh geez, there's a lot of questions coming in here. Or actually comments, let's see. Great work, everyone. Proud of you all, from Dr. Nelson. Curtis, always amazed at the growth students have had in their 4 years here. Excellent job. Robin Tyndall, these are impressive projects, articulately explained. Great, thank you. Amazing work in what was a challenging year in many ways. Yes, yes. So, so thank you for these comments. Oh, and okay, we've got one from Megan Shaw, who is a Speedy alumni from, who is at Raytheon now. She says, impressive presentations. You have great presentation skills and have worked so hard. Always love to see what you all can do in SolidWorks. Impressive. So, oh boy, here we're just getting a lot of accolades. This is wonderful. So Carrie, so nice to hear all of your positive comments about your mentors at KSC. Yes, it's heartfelt. One characteristic about Speedy students that I continue to be impressed is by your attitude towards continuously revisiting a project to further improve it. Did you come in with this attitude, or was it developed while at KSC? If developed here, what do you credit it to? That's a great question. So I'm thinking who might did you come in with this attitude of continually wanting to revisit, or did you learn it here, developed it at KSC? I don't know. Let's see, who might want to answer that? How about Liam? Do you want to give that a shot? Or anyone else want to jump in?
Yeah, when I first got to KSC, I wouldn't call myself a perfectionist now, but I definitely have a little bit of that in me. And I think that slowly developed throughout the 4 years of me being here. I used to just think, it's done and just put it away. And now I have the mindset of, it's okay. It's not quite done. It's not done until I see it as perfect. So yeah, I guess it was developed to some degree here, which was nice.
Nice. Okay. So a question for Aiden. So this is about the Nanoform X. I enjoyed your sharing use of the Nanoform X. Do you have interest in applying those manufacturing skills in the region within optics or precision manufacturing industry?
So I really enjoyed using the product, and I'm not against it. It's just that I'd probably like to work back in Rhode Island, where I'm from. That's kind of my goal right now, at least, is to get out of Keene for a while anyway. I feel like I've been here for quite some time now, but it has gone quickly. But so that's a maybe, I guess, if the opportunity arises somewhere else near me.
Yeah, right. So that's something you could look into, that industry all over the region. I know our whole region needs folks that want to support these industries, because there's a lot of work going on. And then, let's see, whoops. Do I have another question from Mark Gempler? Let's see. So I think so I want to thank everyone here. I'm seeing, hopefully I'm not missing any of the questions here, but I know we've been thank you all for hanging on here. We've gone a little longer, but there's been some really interesting projects that you've all talked about, and I've been getting text messages and emails about how people are enjoying all that you're talking about and sharing your process and how you actually went through all of that. So, so once again, thank everyone who's joined us for the webinar, and have a great. I want you all to join us. So I'm talking with the students here with our luncheon on Friday. We're going to have some fun, and thank you all for joining us this evening.